In the previous video we were looking at standing waves on both strings and air columns, and they're both examples of resonance. Before we talk about what resonance actually is though, we need to talk about what a natural frequency is. The examples that we saw of the standing waves on strings and air columns are examples of natural frequency. And a natural frequency is simply the frequency at which an object will vibrate, and by vibrate we mean it could be the air in an air column or it could be a string, and it will vibrate when it's stimulated. And by stimulated, it might be something like blowing air into an air column, it might be striking an object, it might be plucking a string. And so in each of those situations the tone or the vibration that you would see or hear is then an example of a natural frequency. It is independent of that stimulus, so whether it's being struck hard or soft, it won't change the natural frequency, but it does depend on a few factors. So dependent on the size, shape and composition of the object. As an example, we've got a couple of wine glasses. We'll have a look at those and the natural frequencies that they produce. So here you can see two wine glasses. They're slightly different shapes. One's a bit taller than the other as well, both made of glass, and if I strike the first one, you can hear that it produces a nice tone, and then with the second glass, if I strike that one as well, you can hear that it produces a lower tone than the first one. So they're the natural frequencies of those two glasses. So there's one example of a natural frequency that you can hear when a wine glass vibrates. The idea of resonance then is that it's going to occur when a system is forced to vibrate at its natural frequency. And when we're talking about a system, it could be the wine glass that we just saw, it could be, say, a child on a swing. It doesn't really matter what the system is, it could even just be an object, but ultimately we're forcing the object or the system to vibrate at its natural frequency. Note here I'm saying one of its natural frequencies, so there will be potentially a range of natural frequencies depending on the object itself, and depends on the way that the force is being applied or the way that the system is oscillating. Again, let's go back to the wine glass and have a look at how we can get resonance to occur in a wine glass. So here we have the smaller of those two wine glasses we saw before. Now on my finger I've just got a little bit of water, so that when I rub my finger around the rim of the glass is resonating at its natural frequency. And at the end, even after the driving force has been removed, you can still hear the glass producing its natural frequency as the vibrations start to die down in the glass. Now, one of the key things about resonance is that when it occurs, we have an efficient transfer of energy. So energy is transferred efficiently, and so in that example of the wine glass, a simple movement of my finger across the top of the wine glass caused the kinetic energy to be efficiently transferred into sound. And as a result, the amplitude of those oscillations will grow. And that's the reason why we could hear that sound from the wine glass so clearly. It's because the wine glass, with the correct application of the force that caused the oscillations to become larger, and that means that the sound is then much easier to hear. In some cases that can be quite a dangerous situation. We'll have a look in class at a few scenarios throughout history that have been particularly problematic. We'll even look at how you can use sound to shatter a glass when you play the natural frequency of that glass back to the glass itself, and therefore cause the glass to actually shatter because the movement of the glass is too great for the forces that bond all the glass particles together.